Hey everyone, and welcome. Today we're going to tackle something that sounds way more complicated than it actually is: object-oriented programming. You'll hear it called OOP for short. Now, I know it can sound a little intimidating, but trust me, by the end of this, you'll see it's as intuitive as building a house from a blueprint. So let's just dive right in. All right, so to really wrap our heads around OOP, we're going to lean on one simple idea, a metaphor that's going to make everything else just click. Because think about it, before you build anything, especially something complex, you've got to have a plan, right?
Just picture an architect's blueprint. It has every single detail, doesn't it? It says how many rooms there are, where the doors and windows go, all the measurements. It's the perfect plan, the master template. But it's not a house you can actually live in. Not yet, anyway.
Okay, now picture the real house that gets built from that blueprint. And here's the cool part. From that one single plan, you could build one house, or you could build a whole neighborhood of houses that look exactly the same. The blueprint is the idea, the house is the real thing. Just keep that in your head. It is the key to all of this. So how does this whole idea translate into writing code? Well, let's trade that architect's drafting table for a programmer's keyboard and take a look at what a digital blueprint looks like.
And here it is. This block of code you see, this is our digital master plan. In the world of programming, this blueprint is called a class. We're going to go through this dog class bit by bit, and you'll see exactly how it all fits together.
Okay, so here's the official definition for you. A class is our template. It defines two really important things. First, what kind of data it holds, like the number of bedrooms in our house example. We call those attributes. And second, what it can do, like opening a door. We call those methods. So it's what it is and what it does. And it all kicks off with this one simple line right at the top. Class dog. That's it. That's the moment we tell the computer, hey, pay attention. I'm about to lay out the blueprint for what it means to be a dog in my program.
Now, every good blueprint needs some setup instructions, right? The part that says what to do first. In Python, that's the job of a special little method called the constructor. You'll always see it written as __, init __. It's special because it runs automatically the second you decide to create something new from your blueprint.
See it right here in the code? This __, init part is where we set up all the unique details for each individual dog we create. It's designed to take in a name and an age, which guarantees that every single dog we make from this blue part has its own identity right from the get-go.
So those pieces of data we were just talking about, things like name and age, those are called attributes. You can think of them as the specific details you jot down on the blueprint, like paint the front door blue or the living room is 200 square feet. They're just the variables that belong to our class.
Now, this is a really important distinction. There are actually two types of attributes. A class attribute is something that is shared by every single object created from that blueprint, but an instance attribute is unique to each individual object. And if we look at our code, you can see both. Species up here is a class attribute. It means every dog we ever create from this class will have the species Canis familiaris. It's a shared fact. But name and age, those are instance attributes. They get set inside the constructor, which means they're going to be unique for every dog. Buddy is totally different from Max.
Okay, so we've got the data covered with attributes. But what can our dogs actually do? Well, that's where methods come in. A method is really just a fancy name for a function that's defined inside of a class. They represent all the behaviors or actions an object is capable of.
And here's a perfect example. See this bark function? That's a method. It defines a behavior. And because we've put it inside our dog class blueprint, any dog we create, any at all, will automatically know how to bark. So we have gone through our blueprint, the dog class, with a fine-tooth comb. Now comes the really fun part. Let's actually build something with it. Let's bring this blueprint to life. And that brings us to the object. An object is the real tangible thing you create from a class. It's not the plan anymore, it's the real deal. It is the actual house with a specific address and blue paint on the door built using that generic blueprint. If you look at the bottom of our code snippet, you can see this happening right here. Dog 1 and dog 2 are two completely separate, distinct objects. We're using our dog class like a factory. First, we create Buddy, who's 3. Then we create Max, who's 5. Two totally different objects, all from one single blueprint. How cool is that?
So you might be wondering, how do programmers even come up with these blueprints in the real world? It's not just random guesswork.
There's actually a pretty structured professional process that goes into it. Generally, that whole process breaks down into 3 phases. First is analysis, or OOA, where you figure out the problem. Second is design, OOD, where you plan out the solution. And last is programming, OOP, which is the actual hands-on coding we've been looking at.
The first phase, analysis, is all about understanding. You're not writing any code yet. You're just asking questions and trying to figure out what exactly you're supposed to build. What are the main parts of the system? What do they need to be able to do?
Then you move into the design phase. This is where you put on your architect's hat. You take all those requirements from the analysis phase and you start planning your digital blueprints, your classes. This is where you decide what attributes and methods each one is going to need. And finally, you get to the programming phase. This is the construction part. You take all those detailed designs and you actually write the code, turning all those abstract ideas into real working software.
So, we've covered a lot of ground here, right? We went from a simple house analogy all the way to the code itself, and even saw the professional process behind it. You now have all the core pieces of the puzzle. You know, the source material we drew from for this whole thing ends with this fantastic direct challenge. It's not just about passively watching a video, it's about doing. The absolute best way to make this stuff stick is to actually get your hands dirty and try it out. And that leaves us with one final question for you. Think about it. A car, a video game character, a bank account. Almost anything in the world can be modeled as an object. So with this power to create blueprints for anything, what would you design first? Thanks for joining me for this explainer.